Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 10 practice problems that should closely mirror what you'll see on the GED Math test. As a reminder, you are permitted to use a calculator, including a TI-30XS, as well as a reference sheet as you complete the GED Math test. During this video, I will make extensive use of both of those resources, and in the description of this video, I'll include a link to the reference sheet that I'm going to use for today's video. Additionally, I'm also going to include timestamps that are associated with each question in this video. And next to the timestamp, I'll include links to videos where I discuss the topic that's being tested in greater detail. So if at any point you need any additional help, just take a look in the description of this video. And finally, I want to say that in order to get the most out of this video, I strongly encourage you to make an effort to work out all these problems on your own. That is to say, after I read a question, you should pause the video, attempt to work out the question on your own scratch paper, and then resume playing the video to check your solution. So all those things finally being said, let's go ahead and get started with today's video. All right, this first question says a painter rented a wallpaper steamer at 9 a.m. and returned it at 4 p.m. He paid a total of $28.84. What was the rental cost per hour? So in order to figure this one out, we first need to determine how many hours there are between 9 a.m. and 4 p.m. If you want to do it mentally, that's fine. Otherwise, you can always write it out like this. So he had the machine from 9 to 10 a.m. That would be 1 hour. From 10 a.m. to 11 a.m. would be a total of 2 hours. From 11 a.m. to 12 p.m., that would be a total of 3 hours. From 12 to 1, that would be a total of 4 hours. From 1 to 2, that would be a total of 5 hours. From 2 to 3, that would be a total of 6 hours. And from 3 to 4, that would be a total of 7 hours. So all in all, he had this wallpaper steamer for 7 hours. In order to figure out the rental cost per hour, we're simply going to take this total and divide it by 7. So that looks like this, 28.84 divided by 7. And fortunately enough, we are allowed to use a calculator for this part of the GED Math test. So let's just go ahead and plug it in. We have 28.84 divided by 7. And we can see that this equals $4.12, which is C. Okay, so that one was pretty simple. Let's go ahead and move on to the next one. This next one says, what is the value of 36x minus 8y squared when x equals 3 and y equals -6? So I'm going to write this off to the side. The expression that we're given is 36x minus 8y squared, and we're told that x equals 3 as well as y equals -6. As my next step, I'm going to go ahead and plug in x, or 3 for x here in this expression, and -6 for y in this expression. So we have 36 times 3 minus 8 times -6 squared. Now at this point, some of you would probably know how to work this out. That said, you work this out according to the order of operations. And one way to remember the order of operations is via the mnemonic device. Please excuse my dear Aunt Sally, our PEMDAS. And this basically tells you the order in which you work out expressions like this. You start with parentheses and work those out first if there are any. Then you do exponents next. Then you do multiplication and division as they appear in your expression from left to right. And then finally, you work on addition and subtraction as they appear in your expression from left to right. Again, multiplication and division have equal weight, so you do those from left to right, and that's also the case for addition and subtraction. So if we look through our expression here, we can see there are no parentheses. Now we move on to exponents. We can see that there is a exponent of 2. So let's go ahead and take care of that as our next step. So that's going to prompt me just to copy the expression down as is up to this exponent, which I'm now going to work out. And let me clear this real quick. We have -6 squared. So I'm just going to type it in as I see it into the calculator. -6 squared. Okay, so we can see that that is 36. Again, we worked out exponents, so now we're working out multiplication and division as they appear from left to right. We have 2 instances of multiplication, notably 36 times 3 and 8 times 36. So let's go ahead and work that out next. And I'm going to work them out from left to right, so I'm only going to do one at a time. So I'm going to do 36 times 3 next, and that is going to be 108. And I'm just going to copy down this 8 times 36. Now I'm going to work out the second instance of multiplication. And again, I'm going to use the calculator. So we have 8 times 36, and that is 288. So this becomes 108 minus 288, and we've taken care of multiplication and division. The only operation we have left is subtraction, so let's go ahead and do that again. Rather than making a simple mistake by doing this by hand or mentally, just plug it into your calculator. So we have 108 minus 288. And we can see that is -180, which is answer choice B. Okay, so there's that one. All right, this next one says Annie is planning a business meeting for her company. She has a budget of $1,325 for renting a meeting room at a local hotel and is providing lunch. She expects 26 people to attend the meeting. The cost of renting the meeting room is $270, which inequality shows how to find the amount X Annie can spend on lunch for each person. So in this case, we're going to have to use our knowledge of inequalities to write an expression to mirror what's happening in this word problem. The very first thing that should jump out to you is that she can't exceed her budget. So whatever we put in the left-hand side of this expression cannot be greater than her budget, which is $1,325. That said, she can spend every dime in her budget, so we're going to use less than or equal to. We know that she has a fixed cost of $270, so we'll go ahead and do 270. And we know she's expecting 26 people to attend, and she wants to know how much she can spend to buy lunch for each of them, which we're going to represent with X. So this is the expression that we are looking for. And we can see this one has 270X. That doesn't make sense. That doesn't make sense. It is right here. Okay. This one says her budget can be less than or equal to, or the amount she spends can be less than or equal to her budget. And this one says the amount she spends can exceed or be equal to her budget, which we know can't be true. Okay, so that's that one. In short, this one required you to be able to translate a word problem into an expression. All right, this next question says Dominic earns $285 per week plus an 8% commission rate on all of his sales. If Dominic sells $4,213 worth of merchandise in 1 week, how much will his total earnings for the week be? So for this one, it's going to be helpful to write a small equation to figure this one out. We're going to write weekly pay here, and that's going to equal, we know he gets $285 per week no matter how much he sells. So we're going to include 285 here. And then we're told he gets an additional commission rate of 8% on all of his sales. So I'm going to represent this 8% in decimal form, which is going to be 0.08. And I'm going to represent how much he sells with the variable x. So by figuring what 285 plus 0.08x is, we'll know what his weekly pay is. In this case, we're told he sold $4,213 for 1 week. So we're going to plug this in place of x. So let's go ahead and do that. We have 285 plus 0.08 times 4,213. And again, we can use our calculator to quickly figure this out. We have 4,213 times 0.08. And then we have to add that to 285. And I'm not going to skip a step, so let's just do this step by step. We have 285 plus 0.08 times 4,213, which is 337.04. So now let's go ahead and add these together. So that's 622.04. In other words, if he sold $4,213 worth of merchandise, he would make $622.04 for that week. Okay, so that was that one. All right, so for this next problem, we're going to have to interpret some data that we're given. So let's go ahead and take our time as we read this one. It says a scientist is studying red maple tree growth in a state park. She measured the trunk diameters of sample trees in the same month every other year. The tables show the data for two of the trees. Okay, so we can see we have tree 1 from year 1 to 13, and she recorded its diameter. We have tree 2 every other year, as well as the diameter of its trunk. Additionally, we're told this is the final year in which she will collect data. When her data collection is complete, she will predict further red maple tree growth. Okay? So this first question, which is to the right of this blue bar, says the scientist plots the data for tree 2 on a coordinate grid. So we're concerned with tree 2 for this problem. She begins by plotting data for year 3 and year 11. So we're looking exclusively at year 3 and year 11. What are the locations of the 2 points on the coordinate grid? And when you take the GED, you're going to be able to click on this coordinate grid to add your 2 points. So in order to answer this one, we have to realize that this data that's given here is nothing more than ordered pairs. And ordered pairs are always of the form x, y. And if we take a look at our chart here, we can see that diameter runs along the y-axis, so we know this is our y, and year runs along the x-axis, so we know this is our x. So if we want, we could go ahead and just make these into a set of ordered pairs, and likewise we can do it for this one. I'm going to pull these off to the side just to make it a little clearer. We have 3, 12, as well as 11 and 14.4. Again, this is our x, this is our y, this is our x, and this is our y. Let's go ahead and plot year 3 on this coordinate grid. So x is 3, so we come down here to our x-axis. We go over 1, 2, 3. Y is 12. So now we're looking at this axis, and we go up 12. And you can label it if you want. This is 3, 12. For the next one, we know x is 11. So let's go to our x-axis and go over 11. Y is 14.4. So again, y is along this axis. So we're going to go 11 and up 14.4, which is about right here. So this is 11, 14.4. Okay, so that's all there is to this one. You just had to realize that the data that you're given is nothing more than ordered pairs. All right, so nothing on the left-hand side has changed. That said, we have a new question on the right-hand side of this blue bar, so let's go ahead and see what that says. This one says, the scientist creates an equation that models her data for each tree so that she can predict the diameter in the future. Complete a linear equation. This should be equation. Complete a linear equation that fits the data for tree 1, where x is the year and y is the trunk diameter in inches. Click on the variables and the number you want to select and drag them into the boxes. So, in other words, we have to write an equation of a line for tree 1. Okay? And if we go to our formula sheet, you can see that we do have formulas we can use to write equations of lines. We're going to need this slope formula, which is m equals y2 minus y1 over x2 minus x1. We're going to need to know that the slope-intercept form of the equation of a line is y equals mx plus b. And we're also going to use the fact that the point-slope form of the equation of a line is y minus y1 equals m, which is slope, times x minus x1. So let's go ahead and go back to this problem. Again, we're just writing the equation of a line for tree 1. So as we can see, our answer is going to be in slope-intercept form. So it's going to be of this form, y equals mx plus b. So we know this is going to be our slope, which we have to calculate. This is going to be x, and this box is going to be b, which we also have to calculate. So let's go ahead and work on doing that. The very first thing you need in order to write the equation of a line is your slope. So let's go ahead and start by writing down that formula. It was y2 minus y1 over x2 minus x1. Where do you get x1, y1, x2, y2? Again, you can pull those from the chart since these are just ordered pairs. And let's go ahead and write those over here to make it a little bit easier to see. The first ordered pair I'm going to write is going to be 1, 18.6. And the next ordered pair I'm going to write is 3, 19.2. And we can label them accordingly. Let's let this one be x1, y1, x2, y2. All right, now it's just a matter of plugging these values into the slope equation accordingly. Again, y2 is right here. It's 19.2. So in place of y2 in our equation, we're going to put 19.2 minus y1, which is right here, that's 18.6, all over x2, which is right here, 3 minus x1, which is right here, and that's 1. We can work out the denominator pretty quickly. 3 minus 1 is 2. And we'll use the calculator to work out our numerator. Again, that is 19.2 minus 18.6. So that's going to be 0.6. And 0.6 divided by 2 is 0.3. Therefore, we know our slope for the equation of the line that we're trying to write to represent the growth of tree 1 is going to be 0.3. So this would be 0.3. Now we just need to figure out what b is, and there's a couple ways you can go about doing it. I prefer using the point slope equation to do that. And again, if you recall from the formula sheet, that was this. Y minus y1 equals m, let me fix that, m times x minus x1. Again, y1 and x1 are just the points from our ordered pair. We know what m is, it's 0.3, so let's just plug things in and solve for y. So y is just y. y1 is 18.6. M we figured out was 0.3. X is just x, minus x1 is just 1. Okay, so as our next step, we're going to take this 3 and distribute it to this x as well as to this negative 1. So this is y minus 18.6 equals 0.3 times x is 0.3x. 0.3 times negative 1 is negative 0.3. Again, anything times 1 is just itself. Now we're going to just add 18.6 to both sides to get it by itself. This will cross out here, leaving you with just y on this side. Again, this is y equals 0.3x, and then we have negative 0.3 plus 18.6, so we can go ahead and work that out in the calculator if we want. Otherwise, you could do it mentally. Again, we can just do 18.6 minus minus 0.3. So that's plus 18.3. Again, we can see this mirrors what we have so far. We have y equals 0.3x right there. And we can see our b, which is right here, is 18.3. So this is 18.3. And this is the equation of the line that will predict growth for tree 1. Okay? All right, so as was the case for the previous problems, nothing on the left-hand side has changed, but we have a new question on the right-hand side of this blue bar, and it says in year 13, the scientists will put a tree wrap around the tree 1 to protect it from the winter snow. The height of the tree wrap needs to be 45 inches. And as we can see, we have a nice little diagram here where we have the tree wrap in green and the height of it as 45 inches. Additionally, we're told the wrap is priced by square foot. To the nearest square foot, how many square feet of wrap does she need? Okay, so there is a lot going on in this problem, and it may not be obvious right away. Let's start with the basic parts, and we'll address them one by one. So according to the problem, we're working with tree 1. More specifically, we're working with year 13, and we're trying to determine how many square feet of wrap we need to put around this tree when it's 22.2 inches in diameter. Okay? With that identified, let's move on to this second part of this problem. We're being asked to find square feet, and that should be a clue that you're going to be finding the surface area of this wrap. Okay, so squares go with area, cubes go with volume. So in this case, we have square feet, so we know we're going to be working with surface area. Additionally, we also have to be mindful of the fact that we're being asked to figure out how many square feet, but all of the measurements we're given are in terms of inches. We have the height of our tree wrap in terms of inches, specifically 45 inches, and we have the diameter of the trunk in terms of inches as well. So at some point, we're going to have to make a conversion from inches to feet to answer this one accurately. Finally, we have to recognize, above all else, that the shape of this tree wrap resembles a cylinder. Let me go ahead and draw a cylinder over here for you. And let me draw a better cylinder for you. There we go. Now, the difference between a cylinder and this tree wrap is the fact that whereas this tree wrap has no end caps so that the tree can go through it, the cylinders always have two circular end caps. In other words, this circle is solid and this circle down here is also solid. So while we can use the formula to find the surface area of this cylinder to figure out the surface area of this tree wrap, we're also going to have to modify it accordingly. So let's go ahead and start labeling what we have on our diagram over here. That way, when we go and work with the surface area formula, we don't have to go back and forth. So again, we know the height of our tree wrap is 45 inches. That said, I'm going to convert inches to feet right now, so that way I get it taken care of and out of the way. So again, to convert inches to feet, you divide by 12 since there are 12 inches in a foot. So 45 inches divided by 12 means 45 inches is the equivalent of 3.75 feet. So the height of this tree wrap is 3.75 feet. And we also know, thanks to that chart to the left, what the diameter of this tree wrap is going to be as well. Again, diameter refers to the distance between or from one edge of the circle through the center point of the circle to the other edge of the circle. And in that case, we can get that information right here. Again, the diameter of the tree trunk is 22.2 inches. Therefore, we know the diameter of this tree wrap is going to be almost exactly 22.2 inches. So let's go ahead and label that. Again, and while we're at it, we're going to go ahead and convert that to feet as well by dividing it by 12. So 22.2 divided by 12 is 1.85. So we know the diameter of this tree wrap is going to be 1.85 feet. Okay, so we've made our conversion, so we're good there. The only other modification we need to make is to the surface area formula for a cylinder. So let's go ahead and work on that next. And in case you don't know what the surface area formula for a cylinder is, you can always refer back to your formula sheet. It is right, where is it? It's right here, and I'll write it big so we can see it. Surface area equals 2 pi r times height plus 2 pi r squared. Okay, so let's go ahead and transfer that back to where we're working. Again, that's 2 pi r times height plus 2 pi r squared. Now, again, this is the formula to find the surface area of a cylinder, and it's broken down into two parts. This first part right here finds this surface area, just the curved vertical area of a cylinder. So, and this part right here, 2 pi r squared, well, pi r squared is the formula to find the area of a circle. Multiply it by 2, and that's to find the area of the circular end caps, which we don't need. So in order to modify the surface area formula to work for our tree wrap, we're simply going to lop this off and not use it. Okay, so the formula we're going to use is surface area equals 2 pi r times height. We know what height is. It's 3.75 feet. We know what pi is. We know what 2 is. The only other thing we need to figure out is the radius of our tree wrap. Again, 1.85 feet was the diameter, so we can't use that in place of r. Radius is always half the length of a diameter. Again, on a circle, radius goes from the center point of a circle to the edge of a circle, and it's always half as long as a diameter. So to find the radius of this tree wrap, we're going to take 1.85 feet and divide it by 2. So this is going to be 1.85 divided by 2, and we can see that is 0.925 feet. Okay, now that we have all those pieces, we can just go ahead and plug them into this formula and get this problem done. So we have surface area equals 2 pi, r is 0.925, and height is 3.75. Let's just go ahead and plug this all into our calculator. We have 2 times pi times 0.925 times 3.75, and we can see that that is 21.794. So this is surface area equals 21.794. According to the problem, we can round to the nearest square foot. So that means we're rounding right here, which means we're going to look at this 1. We're going to look to the right of it. And if the number to the right of it is 5 or bigger, we round up. If it's 4 or below, we keep it the same. So since this 7 is bigger than 5, we know this is going to be 22 feet squared, which is A. All right, so very challenging problem. A lot of moving pieces to get it right. Again, you had to convert inches to feet. You had to modify the surface area formula of a cylinder, which isn't that intuitive or easy. So if you need to watch this problem again, go ahead and do so. With that said, let's go ahead and move on. All right, this next question says, the graph shows the level of ibuprofen, Y units in a patient's bloodstream X hours after the ibuprofen was taken. The level of ibuprofen in the patient's bloodstream increased from blank hours to blank hours. Okay, and we can see that we have these drop-down choices, and here are our choices for here as well as here. So to answer this question, we have to analyze this chart and figure out when the amount of ibuprofen in the patient's bloodstream was only increasing. Okay, so if we take a look here, we can see that from here to here, the amount of ibuprofen in the patient's blood level was increasing. That is to say, it was going up, whereas for the rest of the graph, the amount of ibuprofen in the bloodstream was decreasing. And This tells us we want to know the time or hours, and in other words, we're going to be looking at the x-axis only since that's our variable of time. So from 0 hours to approximately 2/3 of an hour, the level of ibuprofen, as we can see, was increasing. So the answer to this one is from 0 to approximately 2/3 of an hour, the amount of ibuprofen in the patient's bloodstream was increasing. Okay? All right, so this next question says an office uses paper drinking cups in the shape of a cone with the dimensions as shown. To the nearest tenth of a cubic inch, what is the volume of each drinking cup? So in this case, we're just simply going to find the volume of this cone, plug it into that formula, and be done with this. So let's go ahead and get started. I'm going to refer to the reference sheet since I don't know that formula offhand. And we're looking for the volume of a cone, which is right here. And I'll write it so everyone can see it. It's volume equals 1/3 pi r squared times height. So let's go ahead and copy that down. The volume of a cone is found by multiplying 1/3 times pi times r squared times height. And in this case, we don't have to make any conversions from inches to feet, thankfully. So all we do is have to identify our height and radius accordingly and plug them in. Height is easy to find. It's right here. It's 4 inches. And again, we're dealing with a circular base of a cone. And let me go ahead and make another circle. Diameter goes from one side of the cone or a circle to another side of a circle through the center point of a circle. So this 2 2/3 inches is diameter, and we want radius. Again, radius goes from the center point of a circle to the edge of the circle, and it's always half the distance of the diameter. So again, we want to figure out what radius is, and we're just going to take 2 3/4 and divide it by 2. So let's do that. And I'm going to convert 3/4 to decimal form. Again, 3/4 is the same as 0.75. So this is 2.75 divided by 2. So we know the radius of this cone is 1.375 inches. So with the height and the radius identified, we can just plug them into this formula and be done with this one. We have volume equals 1/3 pi. R squared is going to be 1.375 squared. Height is 4 inches. So let's go ahead and plug this into our calculator. We have 1/3, which I'm going to put in parentheses like this, times pi. And then I'm going to put 4 first so I can put the exponent at the very end. So this is times 4 times 1.375. And that is squared. So we can see the volume of this cone is 7.919. So 7.919. And it says to round it to the nearest tenth of a cubic inch. So here's 10. Here's our tens place, hundreds place, thousands place. We're rounding it to the tens place, so we're looking at this 9. More specifically, we're looking to the right of the 9. And if this number to the right of the 9 is 4 or less, we don't do anything. If it's 5 or greater, we round up. In this case, we can see it's 1, so this is just going to be 7.9. Okay, so the answer to this one is B. All right, this final question says, There are S steps from the pedestal to the head of the Statue of Liberty. Pedestal is just another word for base. Um, the number of steps in the Washington Monument is 27, less than 6 times the number of steps in the Statue of Liberty. Which expression represents the number of steps in the Washington Monument in terms of S? So in this case, we're going to have to take this word problem and convert it into an expression. So let's go ahead and do that. We know that the Washington Monuments, the number of steps in the Washington Monument is 6 times minus 27 than the number of steps in the Statue of Liberty. So that looks like this. 6s, where s refers to steps, minus 27. Okay? And that's that one. These with inequality signs don't make any sense whatsoever. Okay, so that's it for this video. I hope you found it helpful. As you saw, some problems were more challenging than others, but all in all, this was a pretty good representation of what you may see on the GED Math test. If you like the content I'm creating, please consider subscribing to my channel. In the future, I will be making more videos like this one. As always, you're also more than welcome to leave feedback in the comment sections below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.